Hello everyone, welcome back to my channel Code Cruxes. Today we will solve the same problem of floor and ceiling finding of a number in an array which is given to us, and we have to find the floor and ceil of a number which is x. Okay, so we have written the iterative approach already. You can watch my previous video if you have not. And now we will think about the recursive approach for the same. Okay, so for here in this approach we have three cases. If our mid element becomes equal to x, then we have found both floor and ceil. But if our middle element is greater than x, that means obviously the greater property is for the ceil, so we assign ceil as a mid and declare high as mid minus 1. Why do we did that? Let us recap. Suppose our array is 1, 2, 4, 5, 6 and our x equal to 3, then our mid is this, right? It is bigger than x and hence it can be the ceil of 3. But it is possible that 3 is also present in the array. So we may move to the left hand side in order to search for the smallest element which is bigger than 3 or equal to it. Okay, similarly this is for the floor. The third case. Now we will think about the recursive approach. First of all, in the recursion, let's write for ceil function. Okay, for the ceil function, we will pass low, high, our array, and the number x, right? Under it, we can have the first boundary case that if low becomes greater than high, then simply we have to return -1 because in this case, we are getting out of bounds and hence our answer is -1. Another case can be when a of, we are finding a ceil, right? So when a of high, the highest number is smaller than our x, then also in this case we have to return -1. Why? Because this means that suppose this is our array and suppose our element is 10, then the highest element is 6, which is also smaller than x. That means no element exists which is smaller than 10. Oh, sorry, which is greater than 10, and hence the ceil of 10 will be -1, and hence we will return -1 in this case. But now we have to like declare mid which is low plus high by 2, as you all know, and now we will check for mid condition. It is if the nums of if a of mid becomes greater than x. That's exactly what we want. If an element is greater than x, then we have found the ceil, right? Then we can there is a possibility that this element is ceil of x, but we also need to search in the left hand side, same condition, so that we can get a smaller element, and so we can return ceil. Again the function ceil, the low will remain as it is, but the high in this case, why is my low? Yeah, low will remain as it is, but the high will become mid. Why not mid -1? Because 4 can also be a potential solution for ceil, right? So mid is also needs to be included, and hence we declare it like this, and then a remains as it is and x remains as it is. Okay, let's remove this error that keeps coming. Yep. I don't know why it is coming. So we do it like this, low plus high by 2. Okay, you know this already. So mid equal to low plus high by 2. Now for the same case we will, so that it becomes visible. Okay, now another case will be else. If this remains like this, we have no issues, but another case is else. What will happen? What we'll do, it means that our middle element is smaller than x, and then that means we have to search in the right hand side, right? So in that case we will return, we will simply return ceil, and our low will become mid +1 because mid is not the solution in this case. High will remain as it is, a and x. This can be the code, the recursive code for the ceiling finding, and similarly we can write code for the floor as well. So let us see in the code, because we are good to go now. We have made the basic crux. Writing the recursive steps is the crux in recursive solutions, right? And hence we have did it. So let's go to codes. Okay, so these are the codes for finding the floor and finding the ceiling, right? Here, what I initialized a pair answer with -1 and -1 for both the floor and ceil. Then I took low, high, and n, and I called the functions floor and ceil for finding them. Okay, so let's see the ceil first. This is for checking the out of bounds case, as we have seen in our whiteboard. This case is for when our element is the biggest element, like our element is 10 and our nums array is simply 1, 2, 3, 4, 5, right? So in this case, we will have to return -1 because there is no ceil existing. In this case, it says that if nums low is greater than or equal to x. What does this mean? Let's see. It means that if suppose our nums is 1, 2, 3, 4, 5 and x equal to 10, right? It says that if nums low is greater than equal to x, what we are checking here is we are checking for the high, right? Yeah, here. If a high, this is checked, and now we are checking for another case that if nums low is greater than or equals to x. It says that simply suppose our array is like this 12, 13, 14. This is also another case which we missed on the whiteboard, so we'll cover it here. It means that our array is this. Then you can clearly see that our nums low is 12 while our x equal to 10. So surely the ceil will be 12 because every element which is after it is obviously bigger than it. So this case includes that case. Then I had declared mid, and this code is similar to the what we have discussed on the whiteboard. This is for the case when nums mid is greater than x. That means the solution exists and we have to search for a smaller solution. So we move to the left side, and in this case we move to the right side because the solution is not yet found. To the right side, right? Similarly, this is the code for the f floor, which is very similar to this. You can try it on your own. If you have any doubts, you can ask. Just I have to cover this crux also because I have missed this point and my code was not getting submitted. Here we have to keep in mind that the mid does not get equal to low, because if that happens, suppose I have my nums as what's the case in it, 1, 4, 6, 8, 9. Okay, I'll take the same example, 1, 4, 6, 8, 9, and my x equal to 2. Okay, so in this case, first of all, this will become mid, as this is greater than it, so we are searching for floor, so we will move in this side, right? Then our 4 will become the mid, but it is still greater than 2, so 1 will become mid. But see carefully, when 1 is becoming the mid, it is also equals to low. If we do not write this case, then according to our bounds checking, the low is not equal to high. We are not considering that case, so we will go into what is called an infinite recursion and our code will fail. Okay, so this condition is important to avoid this case. So whenever we check this and mid becomes equal to low, that means we reach the corner. So in the corner, if this element will always be the floor for x equal to 2 or any element x. Okay, so this was another crux. This is a little bit hard to understand, but if you watch it again you can. Okay, and I think that this ends our video. This is the most important thing, like to think recursively, to write according to the recursion formula to update these low and high values. And if you get this, you get recursion as well as you can implement it in the binary search as well. So I hope you enjoyed the video. Thank you for watching, guys. Bye bye.